Hey, good afternoon, everyone. Thanks for coming along to this. My name's Robin. I work for Confluent. We're one of the companies who contribute to the open source Apache Kafka project, and we also have our own distribution of Apache Kafka called Confluent Platform. And this afternoon, I want to show you how you can build streaming data pipelines using Apache Kafka, using something called KSQL, which is a streaming SQL language on top of data that you've got flowing through Kafka. So just a quick show of hands. Who's using Kafka today? Awesome. Who's using Kafka Streams? Who's using Kafka Connect? OK, so I'm going to talk about Kafka Connect. I'm going to talk about CaseEqual, which is built on top of Kafka Streams, but it all does similar stuff. But just to kind of set the scene for what we're talking about here, we're talking about Kafka as an event streaming platform. We're not talking about Kafka as like a replacement for a message queue, or Kafka as just like a dumb little message bus to get stuff into Hadoop. Kafka is a platform on which you can build real-time applications, and not only real-time applications, but integrate all of your different systems together, driven by the power of events. So you can bring in data from your databases, from message queues, from flat files, from your applications, from REST endpoints. You can use that within Kafka, applications feeding from Kafka, and you can write it down to other places as well. But it acts as this platform on which you handle all of your data and all of your events. So people use Kafka in different ways. Like I said, sometimes people use it as kind of like just a way of getting data from here into there. And it's very good at that. So we can use it for taking data. Maybe we want to offload work from a database. We've got an expensive transactional database sat over there, and we want to do analytics on that data. So we say, well, let's get the data over there and put it somewhere more appropriate for that kind of workload. So we're going to shove it up into S3, or we'll put it onto HDFS locally, or we'll put it somewhere where we'd rather be working with that data. And Kafka works great there. It provides this integration point, it provides back pressure, it provides availability, and it also decouples where we've got the data coming from and where we're using the data. So one of the important things here is you'll see that you've got the data not only going up to S3, but also to HDFS. But it's coming from the same place. Because Kafka persists data. You can get Kafka to persist data for a few days or a few years, or based on size, or indeed forever if you want to. It depends on how you're using that data. But because Kafka persists data, it means you can replay it. So we've got HDFS over here. Let's say it goes bang, or we're using Elasticsearch, we want to repopulate it. You can simply replay that data out of Kafka, and you can consume it multiple times. So we write the data to different places completely independently. We can add them in, take them out. It doesn't affect anything else. So we start to really benefit from this idea of more loosely coupling what we're doing with our data. But Kafka itself provides stream processing capabilities. It's not just a way of passing events around and connecting systems together. You can actually say, well, the data that we're passing from our relational database down into somewhere where we're doing analytics, maybe it's in a normalized form, and we want to denormalize it down, suitable for use as a data warehouse or for doing analytics on top of it. Usually doing this kind of pattern, you still end up doing a batch process over here, writing a Spark job to do this, or writing a job over there. So you got all this lovely real-time streaming of data, and then you decide, actually, we'll wait for a bit, and then we'll process it as a batch. But you don't have to do that. You could say, well, as the data comes through, we've got order data in the database, we've got customers data in the database. As it comes through, we can actually join those events using stream processing in Kafka and write the result out to somewhere ready for analytics. So you don't have to have these multi-step things and batch things over here. As your events occur in your business, you can be enriching them straight away. The benefit of also doing this is that by decoupling these pieces, it makes it easier to evolve your architectures. So today, you've got orders and customers in a database. Tomorrow, maybe you move your order processing out to a new service that you've written. That service, instead of writing down to a database where you then bring in that data from, that service instead writes it to a Kafka topic. But because we've decoupled the pieces, our consumer at the end here still just pulls in those enriched orders. The stream processing potentially stays the same as well if that order data has the same schema. And if it doesn't, well, we just put in another stream processing job to make the schemas do what we want to. But it makes it much easier to make changes as we go through. So you can use Kafka also just as a bus between your different applications. You can use the stream processing capabilities, maybe to take a stream of orders, and we want to create something separate which says, well, I've got an application over here. It only needs to know about completed orders. So I guess that application could subscribe to the topic of all of the orders created and then filter them out itself. But actually, we could write a little stream processing job which says, take this stream of orders and create a second one just of completed orders. So now we have two separate streams of all orders and completed orders. Our application down here, all it has to do is subscribe to that new completed orders topic. But by transforming it once, we can use it many times. So as well as our application wanting that, we can now also have reporting and analytics on top of that same information, which orders have been completed. So you can bring your transformation, your processing inwards if you want to. Or you can do it wherever you want. Kafka's not kind of opinionated on that, but it gives you this ability to do that processing. You can also use Kafka as a way of moving from older systems towards new ones. Let's say we've got our kind of great big hairy monolith and it's sat on top of a database, which is how we always do these things. And we're writing all of our state down to this database. We think, wouldn't it be nice to be able to break this up and kind of do things a bit differently? So instead of kind of blowing it all away and starting again and waiting for that once every 10-year greenfield project, we can say, well, why don't we take those events as they're being written to the database, and we can start to stream those into Kafka. So we're not modifying the existing application. We're simply tapping into the transaction log of the database, and we stream those into Kafka. Once they're in Kafka, we can write new services which subscribe to those events and start processing them. Oh, there's a new order being created by the application over there that we know nothing about, but there's a new order. I can start to do something with that. We've got a new customer being created. So you can then start to add in these new applications driven by the events from your existing systems, also driven by events of those applications themselves, so using it as a broker between themselves. And if you then actually get to the point where you don't need that old application anymore, well, you just turn it off. Your existing applications that you've built, they're already nicely, loosely coupled from it, so you can do that kind of migration more easily. So those are some of the things that people are doing with Kafka. There's lots of different ways to use it. You need to kind of find the one which is appropriate to what you actually need, what your requirements are. But I want to show you now an example of how you can kind of build these things up. And the example here is not having to use any coding. I'm cheating because I don't code. I code, but not Java. If you're a Java person, I suspect quite a lot of you are, there's a Kafka Streams library, there's a Kafka API that you can use from Java. But here we're going to show how you use Kafka Connect and CaseEqual. But the concepts of what we're building up are exactly the same. So the fictitious scenario that we've got here, we've got a website. And on our website, people can leave ratings. They can say, I really like your product, or your product sucks, or whatever. And these ratings get written into Kafka. So our website's using the API to write them into Kafka. Who these people are who are leaving these ratings, we don't know when they leave them. They simply say it's a user ID 42. Who is that user? We want to know who that user is, because if they're leaving a bad rating, we probably want to follow up with them. Or we want to say, well, is this a particularly important user? Because if it is, we definitely want to know about it. So we can get our user information from the database, and we can synchronize what's in the database, not only a snapshot of it, but every single change that happens in the database into a Kafka topic. Then we can start filtering these events as they're coming in real time, looking for certain patterns in them, looking for certain conditions, joining those information as they come in to information about those customers, and we can do different things with that data. We could stream it down to the traditional data lake. Let's dump all our data over there and hope that the fairies do something magical with it. We could put it into a real-time analytics application, stick it in something like Elasticsearch with Kibana on top to actually show, here are the ratings that are being left in real time with information about who the customers are. But you could also say, well, when we have really important customers, we've got customers of different status, they're bronze, they're gold, they're platinum. If we've got a platinum customer, that's super important to us, and we want to know as soon as they leave a bad rating. Because that kind of customer you want to love and cherish and make sure that they're not unhappy with your business, because otherwise they'll probably go somewhere else. So you can use this idea of the events coming into Kafka, information that we know about those customers, enriching them, and actually saying, if we've got a really important customer who leaves a negative rating, well, let's send a push notification to our customer team and say, let's get on the phone to them now and see if we can do something about it. Rather than the traditional approach of, let's capture all of this data and chuck it over there and run a batch process that says, oh yeah, last month a really important customer left a bad rating and they never came back, and that was last month. Whereas if, as these events are being created, we can actually be doing something proactively and phoning up the customer saying, really sorry about this, then that's going to make a much better impression. So we're going to use our applications. We've got our ratings events, sending the events in. We've got an application, which is going to do the push notification. We're going to use the producer and consumer APIs. There's libraries for kind of all different languages, and if there isn't one for yours, there's a REST proxy that you can use instead. We're going to use Snowflake or HDFS or something like that for our data lake. Elasticsearch, to drive an operational dashboard, relational database for our user data, Kafka Connect, which I'm going to talk about in much more detail for actually hooking these pieces together, for bringing in data from a database and sending it into Kafka, for taking data from a Kafka and putting it into Elasticsearch, putting it into our data lake, wherever it may reside. And then we're going to use CaseEqual to actually join these events, to filter the events for different conditions. I'm using CaseEqual. You can use Kafka Streams as well. CaseEqual is built on top of Kafka Streams. So all of this is part of Confluent Platform. You've got CaseEqual, you've got the latest version of Apache Kafka, which includes Kafka Connect, it includes Kafka Streams. You've got a schema registry, you've got connectors, you've got all that kind of good stuff. You can run it on premises if you want. You can also run it on Confluent Cloud, where we manage it for you. So the first bit I want to show you is actually how we can do stream processing using CaseEqual. We're going to take this information that's coming from our website as people are leaving these ratings. We're going to stream that into Kafka. We're then going to use CaseEqual simply to say, go through these messages as they arrive and filter out ones with a low star rating. So you can leave a rating 1 to 5, it was good, it sucked. If it was less than 3, then we're going to class that as it wasn't good. We're going to write all of those events to a new topic, because then we can process that additionally. So it just looks like this. Create stream per ratings, create a Kafka topic as select from the ratings where stars is less than 3. So let me show you this in action, how it actually works. What we've got here, if I share my screen with you, that one. Is that big enough at the back? Can you see that? Yeah, good stuff. So this is CaseEqual. It's a command prompt. You can use CaseEqual through Confluent Control Center. You can use CaseEqual. It's got a REST API. I'm using a command prompt because I like command prompts. And CaseEqual gives you the ability to write streaming applications using SQL on top of your data that's flowing through Kafka. It's less about integrating with analytics tools. And there is a community JDBC driver, but it's not really about that. It's not about, I've got data in Kafka, I want to hook it up to Tableau. It's more about saying, I want to define a stream processing job, and I want to express that in SQL. And as we know, SQL is very expressive for saying what you want to do to your data. But you can also use CaseEqual simply as a client with your data that you've got in Kafka. So you can do something like this. I've got CaseEqual, it's connected to a Kafka cluster. What topics have I got on that cluster? OK, show topics. It says you've got various different topics. You've got a topic here called ratings. I guess that's got my ratings information in it. People who work with Kafka today know that Kafka messages, they're just key value bytes. We don't know how it's serialized. We have to know, is it Avro, is it JSON, is it whatever. When we want to go and look at the data in that topic, we have to use the appropriate deserializer. CaseEqual gives you a helping hand here. It says, well, I'll go and have a look at those messages, and I'll take a good guess, and I'll try and deserialize them for you. So we can say, well, print ratings. It says, OK, I'll do that. So then we say, let's go back up here. We've said, we're going to print ratings. Oh, it's in Avro. Because it's in Avro, we'll go to the Confluent schema registry, pull down the schema, and we'll deserialize the data. So at the moment, that's just a screen full of stuff of the live messages as they arrive on that topic. So it's already quite useful for just inspecting the data that we've got in a Kafka topic. But we're talking about SQL here. We're not talking about just dumping the contents of a message to screen. So what we're going to do is we're going to define ourselves, if I find my appropriate cheat sheet, an object. So in CaseEqual, you have this thing called streams and tables. We're going to talk about tables later. This is where it kind of gets a bit mind-bending. We'll keep it simple to start with. We're just going to talk about streams. I'm going to say create a stream called ratings against the Kafka topic called ratings, and it's in Avro. So a stream in CaseEqual is a Kafka topic plus a schema. Because it's SQL, we need to have a schema. We've not actually typed in any column names because we're using Avro. So Avro is a superb way of serializing your data. The schema gets stored in the schema registry. When you come to use that data, whichever client, whether it's CaseEqual or Connect or your own application, can go and fetch that schema from the schema registry and deserialize it and know the full schema of the data. So we can say, well, describe ratings. What does that stream look like? It says the stream looks like this. You've got various different columns within it. They're the different data types, but it's got a schema, and we've not had to type it in. You can use JSON, you can use CSV, but you have to type the columns and data types in yourself, which is error-prone and really tedious. So I like Avro for lots of good reasons. So we've got a stream. I can say show streams, what streams we've got in the system. We've got a stream called ratings. It's modeled against, it's a schema against that Kafka topic called ratings. Now we can select some data from it. So we can say select the stars, the channel, the message from ratings, where stars is less than 3. Let's just cancel that. Let's pare it back just a second and say, let's select all of it. Select just these particular columns. So now we've got the first column is the stars, the second column is the device they used, the last column is the message. And this is all of the data that's in the topic, because Kafka persists data, and then all of the new data that's arriving. But you'll notice it keeps on going. If it actually catches up with the end of the topic, it'll slow down like this, but it's still going. There's still new data arriving, because CaseEqual is a continuous query language. This is not a database. Select star from table. OK, here you go. It might take a while, but here you go. Has it changed? I don't know. I'll rerun it. CaseEqual, it's a continuous query. And this is how we build stream processing applications, because we simply say, take all of that data that may be there already, is continually arriving both now and on into the future forever, take that and write it to a new topic. So you can inspect it on the screen. You can poke around the data. You can say, let's just look at these particular columns within it. Let's filter it out where stars is less than 3. Now we get a subset of the data. You can start to look for conditions within it. You can group by, you can aggregate and all the rest of it. But when you've got your SQL statement that you're happy with, all you need to do, create stream power ratings as. That's all that you do. So in the database world, some of you may know, create table as select. Select from this table, write the results of that into another table. Has the data changed? I guess I'll have to rerun it. In CaseEqual, create stream as select says create a new stream, which is a Kafka topic underneath, populated by the results of this select statement. And select statements are continuous. So we set that running, and instead of getting a screen full of stuff, it says stream created and running. This is good. It's now going. We can say show streams. What streams have we got? We've got 2 streams. One of them is our original ratings one. The other one is called poor ratings, populating a Kafka topic called poor ratings. You can do different things. You can change the Kafka topic you're writing to, the format, and so on and so on. This is just keeping it dead simple to start with. But because we've built a stream processing application and running that create stream as select, we can actually look at it in more detail. We can say describe extended poor ratings. It says, OK, you've got a schema like you had before, but you've also got information about the query that's writing to it. You've got metrics down here. How many messages have we processed that have passed through that? If I rerun it, you'll see that number's changing, because new messages are arriving. If they match the predicate that we set, if stars is less than 3, then they get written to this topic. And it is a Kafka topic. If I say show topics, it says, OK, here's your topics. There's a topic called poor ratings. If I say print poor ratings, it should just print this topic. We're not doing schemas or SQL or anything. We're just saying print this topic. Just be a Kafka consumer. Print this topic. It says, OK, here is your topic that you are populating with all of the data that you asked for, and as the messages arrive, they get filtered, and if they match the predicate, written to this new topic. And because it's just a Kafka topic, you can use that with any application that integrates with Kafka, which is kind of any. You can take that topic and write it down to a target data store. You can use that topic and use it to drive your services that you're writing. You can do anything you want because it's just a Kafka topic. But we're populating it using a SQL statement. So this is CaseEqual. CaseEqual lets you write stream processing applications against data flowing through Kafka using SQL. It's built on top of Kafka Streams. So Kafka Streams API, it's a Java library. It's part of Apache Kafka. If you're using CaseEqual, you just write SQL statements. There's no kind of boilerplate stuff. And what I showed you there is how you write them. It lets you filter messages. We've got a stream of data here, exactly like I showed you. We've got a stream of data. I want to filter out messages that don't match a certain condition or that do match a certain condition. But I can also change the format of them. I can change the structure of them. We've got data coming in. We want to drop a bunch of fields. We want to do stuff like that. We can do that. And it's just SQL. You can also build aggregates. You can say, as my clicks come in, how many clicks am I getting per 5 minute or 10 minute or hour? I've got sales coming in and aggregate them as I want to. You can do tumbling windows, session windows, hopping windows, any kind of windows. Well, not any, those 3. And you can aggregate your data, and you can write that to a new Kafka topic. That can be driving other applications written down to other data stores. You can get a bit more complex with it. You can say, well, let's take advantage of the fact that we can aggregate the data, and we can use predicates and having and so on. We can say we've got an inbound stream of credit card authorization attempts. We can say if someone tries to authorize the same credit card more than 3 times within a 5-second window, let's write information about that credit card to a new topic. We're going to write it to a new topic. That topic can be driving a service or whatever that we want to do. But we're building that pattern matching. We're expressing it in SQL, which is so expressive, and we're running it as a stream processing application. You can transform your data. You can reserialize your data. You can repartition your data. You can change the partitioning key of your data. So CaseEqual is very powerful in working with the data that you've got in Kafka. So far, I've shown you just prototyping, building up applications, running it from the command prompt. You can run it from the command prompt. You can run it from Confluent Control Center. You can run it from the REST API. But once you've written your application, once you've developed your code, and your code is just some SQL statements, you take that file, you put it into your source control, you run your tests against it, and that gets deployed against your KSQL servers in production. So once your KSQL servers are running with that statement, you can't connect to them and change it and stuff. It's just an application. And the code your application runs is that SQL statement. And because KSQL is built on top of Kafka Streams, which is built on top of Kafka, you get all of that elasticity and fault tolerance and parallel processing and scalability that you get with Kafka and Kafka Streams. So you can scale out KSQL as much as you want to. So I've shown you the first bit, filtering the data. Now let's see about getting data in from different sources and writing it down to different targets. For this, we're going to use Kafka Connect. So Kafka Connect lets you bring in data from a multitude of different places, write it down to a multitude of different places, build end-to-end pipelines, or supply your applications with data, or take data from your applications and write it down to where you want to. But the key thing is, if you're integrating with these sources and targets, generally you don't want to be writing that yourself. Generally, Kafka Connect is going to do a better job of it for you because it's scalable, it's fault-tolerant, it handles restarts, it handles schemas. It does all that good stuff that you should be worrying about when you're building these pipelines. It's dead easy to configure. You set up a bit of JSON. You say, I'm going to use a particular connector. Here's the source, URL or whatever, and I want this data from it. And it will stream it into a topic. Or you say, I've got this topic here, and I want to stream it down to this place over there, and off it goes. You can get different connectors from Confluent Hub. So Confluent Platform ships with a bunch of different connectors. There are other ones that you can get. So go and work out which technology you want, type it in, and find the appropriate connector that you want. So let's say it in action. We're going to put in data about our customers. These sit in a relational database where we usually keep that kind of thing. It's in MySQL. The principles I'm showing you apply to any relational system, any relational database, because they all work the same. They all have a transaction log underneath that you can capture the events out of. So I'm using MySQL. I'm using it with a tool called Deserialize, which is a change data capture tool that integrates with Kafka Connect to stream that data into Kafka. We're going to bring it in. We're going to look at that data in KSQL. We're going to join it. And then we're going to use Elasticsearch and stream that data from our Kafka topic of enriched data down into Elasticsearch. So let's do that. To start off with, I'm going to go to MySQL. OK, so MySQL, it's a command prompt. I'm going to say, what tables have I got? Show tables. It says, you've got a table called customers. I'm going to query that table. I'm going to say, show me the data that sits on that table. Show me the first 5 rows. And it says, well, you've got a bunch of data. It's a database. You'd expect to have some data in it. There's data in it. But what I've got running in the background is Kafka Connect. And Kafka Connect, just checking that it's actually running, otherwise the demo falls flat, is taking a snapshot of the data that sits in MySQL, putting it into a Kafka topic, noting where it got to, and then any new changes in that table are going to get streamed into my Kafka topic. So that's MySQL. Now I'm going to head over to CaseEqual. Okay, there's lots of different SQLs. CaseEqual up here, it says Kafka up there to help you remember. Show topics. What topics have we got? We've got a topic here called customers. We can say print customers, what data's in it? It says, well, there's data in it that's come from the database, and we've copied it into this topic. We can also say, well, we've got a Kafka topic. Let's go and model ourselves a KSQL stream and table. This is where it gets funky on top of that data. So in the interest of time, I'm just going to run this stuff. All the code's available, by the way, on GitHub. But that's simply modeling some streams and tables against those topics, populated from Kafka Connect, hooked up to the database. And if I now say show streams, it says, OK, you've got a stream of customer information. Show tables. You've got a table called customers, which is populated from a Kafka topic. And that Kafka topic, by a couple of steps, comes from the database. So we're going from a table of data into an event stream on a Kafka topic, back into something which is a table, or it says it's a table. So let's actually see if it is indeed a table. Let's query it and say, what's the first 5 rows on customers as CaseEqual against a Kafka topic sees it? It says, well, here we go. Here is the state. And it says, here are your first 5 rows. If we compare that to MySQL, we can see in MySQL the same thing. So in MySQL, data, Kafka Connect streams it into a Kafka topic. KSQL can model a Kafka topic as if it's a table and shows it you there. But now this is where it gets really cool. Because if I insert myself a new row, and up in KSQL, I'm going to rerun that query, but take the limit off. So this is now a continuous select running. Here's all the contents of the table as it is currently, and it's a table. It models state. And if that state changes, KSQL will re-emit the row, and it'll say the state has changed. So at the moment, I don't get the command prompt back because it's a continuous query. In MySQL, I make a change. I do it from the command line, my application does an insert or whatever. However the data gets into the database, we have a new row. The new row lands in the database, and it appears in our KSQL table because it's been picked up by Kafka Connect, written to our Kafka topic, and KSQL shows it us. If I make changes to that, okay, so we've got a new customer, we forgot to enter their email address, we forgot to enter their club status. We enter their email address, we get a new update. We change their status, okay, we get a new row up there. We say, well, hang on, this is Rick we're talking about. We should definitely make sure he's platinum. We say he's platinum, and we get a new row up there. But the key thing here is this is a table. This is state for a given key. If I say select from this table where ID equals 42, it says the state for the key 42 is that. That is the current state of that data. If I run the same thing against my database down here, in MySQL, it says that is the current state. The state for key 42 is this. But the super cool thing, and this is called the stream table duality, is that our table was converted into a stream of data, which has then been converted back into a table. But the stream is also useful, because the stream is our events. Our events are our log, or our kind of our base unit, and that's what we need. The state, we can manifest when we want to from that log of events. But we still have the events, because sometimes that's useful. So let's query our customer's stream. So our customer's stream is against the same topic, we're simply modeling it differently. It's a semantic construct on top of the data. Now let's look at the events associated with that key. Key 42 has had 4 different events. It was created, we had an email address, we had to change the status and change the status. And those events themselves are also useful. So the data that Kafka Connect's picking up, it's just sending over a copy of the record as it is now. But Kafka Connect can also show you the before and after. So if I switch over to this, so this is just using a consumer against the topic that we're populating, the customer's raw over here. And this actually shows you the before and after state of the records. So we can see here, before it was Rick and it was no club status. And then we've got a new record comes in here. It says, well, afterwards, they got updated, and they got bumped up to bronze, and they got updated to platinum. But you have the raw stream of events from the database, the before and the after, that can then be driving your applications. So, unfortunately, that was a whistle-stop tour. The stream table duality is a fascinating thing. I gave you a taste of it there. There's slides which I will share. What I do want to share with you in the last 2 minutes is the fact, I could show you in demo, I can show you a screenshot, the data that we were enriching in that demo, we can then pull through into a Kafka topic, so taking those events as they come in, enriching them with information about the customers, writing it back in real time to a Kafka topic, stream it to Elasticsearch, do a push notification. I had the demo set up, it may have worked, it may not, we'll never know. But you can do all of these cool things through the data flowing through Kafka. We've got Kafka Summit just next week, so if you're free on Monday and Tuesday, do come along to it. There's a discount code that you can use. There's all of the code for this is on our demo same repository. We've got some free books you can get from our website. We've also got a really good community Slack group. It's like 9,000 people super interested. If you've got any comments, if you liked it, if you didn't like it, please tweet me, tell me if you liked it or not. And with that, thank you ever so much. We're confident we've got a booth downstairs. I'll be hanging around there if you've got any questions. Thank you.